Oh, guys, welcome once again to the day 5 of our physics chapter wise for UTMA and Waec students 2022. I hope you guys have been, at least you've been improving. And I believe if you actually follow us throughout this course, there is nothing that will stop you from getting a very high score. Like I said, it is just what I think I can do for students. And it was actually requested by one of my students to do this so that people will actually gain a lot from it. And again, I said if I could find time, some are writing mail to me to help them also in chemistry. And the mathematics students are not saying what they are okay to do. So I promise them that to make something like this is not easy because I'm trying to make it detailed, and I'm also making sure that all the concepts are within your level. And apart from that, I'm also trying to make sure that all the questions are the new pattern because this is the most important thing for now. The pattern has changed in recent time, and because of that, many of you are actually finding it difficult to get a very good score. Then again, we are moving very close to those topics, which I think it's very important. Very soon we get there. So don't relent. Tell a friend about the page. I mean, I'm seeing you guys, you are trying, actually watching it, following up. You can still tell one of your friends. And that is why we're on YouTube. I believe YouTube is a platform where you can get a free data to watch. So you can watch in the night if you are those that don't have data. And for those of you who actually believe you know where you are going, I don't think it's a big deal for you to actually watch a video and write one or two things down. In fact, write everything down because it's like a quick revision to help you pass in passing your examination. So I'm engineer again. I'm going to run you through day 5 from question 1 to 10. Now that you are improving, I'm going to be leaving some questions for you to solve. And I'm going to be very fast because you guys said you want it to be a little bit shorter than that. So I'm following your instructions because you are the one that made me make what this. And you have to what? You have to get it there on your own too. So we start. The first one is a kind of multiple choice. We have Roman figure 1 says density of liquid, excuse my voice, excuse me, acceleration due to gravity, the types of containers of the liquid, the constituents of the liquid. The question is, which of the following conditions will not affect the pressure of a fluid? I think concept video you might have studied. The only concept you need to understand here is that pressure of a liquid is given as H rho G. Very important concept, whereby H stands for height, rho stands for density, and G is always gravity. So, and again, you might have learned about this concept that says pressure is also equals to the atmospheric pressure plus H rho G. For your level, this is just what I think you need. Therefore, advanced students, like I do say, I have concept video. I'm not into that, but there is always one thing besides, excuse me, the pressure of a fluid, which is liquid or gas, is not dependent or is independent of the nature of the container or the constituent of the liquid. The pressure is equal. Whenever you draw an hypothetical line, for those who have watched my concept video on pressure and stuff like that, they are available. You are going to understand that what pressure does not depend on the type of container. Either it's a U-tube or it's a bottle. So far an hypothetical line is drawn, pressure does not depend on the type of, so it does not depend on the size of container. It is mainly dependent of the height at which the liquid flow, and that is what we call the gauge period. So here, this density is a factor from what I've explained. Gravity is a factor. Type of container is not a factor. Then the constituent of the liquid is also not a factor. So keep that at the back of your mind. Roman figure 3 and 4 is correct for this first question. The next question says, if the pressure in a confined liquid is changed at any point, the change is transmitted equally to all points of the liquid. This principle or law is said to be that. Now, according to the law that I have explained here, in junior classes, you might have studied that the law of transmissibility, which is popularly called Pascal's principle, Blaise Pascal principle. Pressure applied to an enclosed fluid is transmitted equally to every portion of the fluid and the wall of the containing vessel. Pressure at any point where an hypothetical line is drawn, is always equal, and pressure does not depend on the size or nature of the container. Please always keep that in mind. Pressure mainly depends on the activity. That is the same concept, and that is very good with the way this question is being captured. The next question, excuse me. A body which is 50 Newton in air displaces 3.7 kg of water when it's partially immersed in water. The upthrust on the body is dash. Now, the upthrust on the body, which we call the weight of the body displaced when an object is immersed, either submerged totally or submerged partially. You can watch my videos on Archimedes principle and law of flotation. It is there. Everything is discussed from basic level to advanced level. You can check it out. Now, the weight of the fluid displays. Technically, this is the way you are being taught in junior classes. I'm not going to go into too much of details as your exam require only the surface. So we say the weight of the fluid displays is always the weight in air, weight displays is always the weight in air minus the weight in water. WW. And that is what we call the upthrust. Weight displaced is called upthrust. So basically, you can say upthrust equals weight in air, 50 Newton. Weight in water, weight is mass multiplied by gravity. You and I know gravity is taken to be 10, most cases, or 9.81. 3.7 multiplied by 10. From here, this is 37. Like I said, I'm going to be leaving you to be solving some of those questions. Now you are getting very close to it. So we have to what? Make sure you are also trying one or two things out. So 50 minus 37 will be the upthrust of this liquid, and that is 13.0. If you like, you can say 13. But because the examiner is leaving the answer in one decimal place, I'm going with the examiner, and this is choice B. That's the answer. So, guys, we move to the next question, still under pressure, and we are talking about what? Archimedes principle here and law of flotation, which has been discussed. And there's another thing we call apparent weight, which is tension. Upthrust is equals to tension minus weight, or you say weight equals to upthrust plus tension. So the next question is an hydraulic lift, which is an application of pressure to in a hydraulic lift, compressed air exerts a force, F1. Check my video on pressure. But like I said, this is also enough for you because the way I will organize this, our day-to-day exercise, is going to be in such a way that you won't miss any concept. Just see the way I've been organizing it. It's not easy. So, but I'm trying to make sure I am going to cover all the topics. The air exerts was a compressed air exerts a force of F1 on a small piston having a radius of 5 centimeters. This pressure is transmitted to a second piston of radius 15 centimeters. Very good. If the mass of the load to be lifted, the load that you want to use the hydraulic lift to carry, is having 1,350 kilograms, we have to find the F1, and the pressure necessary to accomplish this task is dash. In fact, the examiner actually give you a light that you have to get the first force before you can actually get the pressure necessary to accomplish this task. And you can see all your options are in Pascal. That means you are looking for the pressure required. So from hydraulic lift relationship, you might have studied that pressure concept is still on pressure. Pressure is force over area. Take it. So if we are talking about hydraulic lift, we said the first area over The first force over the first area is equals to the second force over the second area. This is the way we relate hydraulic lift. So you keep that in mind. I know most of you might have studied that. If I make F1 subject of the formula here, because I'm looking for the first force, it will be F2 multiplied by A1 divided by A2. I hope students don't have mistake in this. The force is the weight that it is carrying. The load is, you can take force equals to mg, because it is carrying a load which we can transform to what? To weight, which is in Newton. The mass of the body is 8,350, and I'm going to take the weight as 9.8. So from there, you can punch your calculator. I don't have time, and I don't have calculator here with me, but I'm going to use assumption, and my assumption will definitely work. I am used to that. For those that are in my offline classes, they know me very well for that. 8,350. You can use 10. It doesn't change anything. You go for approximate answer. Why I'm looking at that is because of the nature of the position of the answer. Times 9.8, which is the first force, a second force, multiplied by area. My dear students, area is pi r square. Area is pi r square. Circular piston, circular lift. That is the way we interpret the piston. Pi r square. The first radius is 5. I can take it because centimeter we cancel out. I may not convert. So that is 5 square is 25. Divided by the second area. That is pi times r square. The second is 15. 15 square. 15 square is 225. From here, my dear students, pi gets cancelled out, and you can also go by what your calculator and get the answer for the force. So, but the question did not ask you about the force. I don't have calculator, and I don't want to be bringing calculator out. The question asked about pressure this year, my dear student. So, pressure, we said just now, is the force, which is the answer you're going to get here, on the second, the pressure on the first stop. So we have the answer here divided by 0.05. Why? I have to change this one now to what? The meter value. So it will be answer I'm having here divided by 0.05. And if you go by that, I think I should have, don't mind me, 1350, my answer for force, times 9.81 times 25. I am dividing by 25, 225, it's not 25, which is the answer, divided by the area. Area is 0.05. If I multiply turn division to sign, that 0.05 will come here. So now all you just need to do now, guys, is to punch your calculator and tell me the value of this. And if you go by what I am saying here, for my assumption, I do say it. I'm very, very good in here. This is 5, this is 5. 5 can go here. Then we are having, this is 10. This is putting 1 0 at the back of this, then what I have here will be like very close to 2. So I'm going to click 1.9 times 10 raised to power 5 Pascal. Like I said, I'm going to be giving you activity to do, and that is exactly what I have done here. So numerical wise, you can solve questions even without calculator. On your system for UTME students, there's always a calculator available for you to use. So in that sequence, we move to the next question. I hope you can punch calculator and do this. And if you have any reservation, drop your comment down at the comment section and we attend to them. So next one, we move. The next question is, I think now on the little concept of equilibrium of forces, we call that center of mass. I have videos on that. You can also check it out. It is very complex, rotational dynamics. So, but for your level, you only watch the peripherals, which are your meter rule and stuff like that, which are not that difficult to understand. Now, we have a mass of 10 grams. It's attached to a 0 centimeter mass of a light metal rule, while the mass of 40 g is attached to the other end of the mark. The center of gravity of a system is located at that. Now, from junior classes, center of gravity is defined as the center at which the resultant weight of a body acts. I hope I'm talking to people. Yes, fine. So the center at which resultant weight at is called center of gravity. The meter is always drawn like a straight line in your junior classes, and we follow the same principle and the same methodology. It is always pivoting at the center at which the resultant weight is acting. Affirmative? Yes, fine. So if you want to actually get this very well, you have to draw. Though I may not draw and tell you this is the answer because I'm used to solving stuff like this time and time again. So the first mark, it's like a ruler. Zero will start at this side. So the weight is always attached directly here. I'll just take it as 10G, the weight is being taken in the question. So permit me to just draw with any color. This diagram is not just clear. So I take 10G. Some people will put something like a box here. Does not change anything. I hope students are with me. Then the other one was attached at the other end. This is the other end from the way I've shown my illustration. I told you diagram not drawn to scale. This is center of mass. Don't worry about that. If you've not learned anything about that, I'm going to take you through it with the concept because in the next video, I think we are going to have more of questions on equilibrium, hopefully from the way we are actually strategizing the piece. So this is 40G and the center of gravity, you and I know. Let's say the distance from here to the center of gravity, like I do say, my diagram is not to scale. Permit it any way it is. You just have to permit it for now. So let's take it red. Then let's say the distance from here to here is taken as x, and the distance from here to here is taken as y. Now, from the basic knowledge you might have studied in your early classes, I took this one as x, I took this one as y. So when you take moment, center of mass action, or moment of force concept is said to be the product of the force and its perpendicular distance. So always keep that in mind. Force is a vector quantity. Now, if we take the moment about the center of gravity, which is G. Now, you said force. I'll take mass as force now. If you like, I can convert it to weight, but I'm not going to convert. So there's always what you call clockwise turning moment is equals to anti-clockwise turning moment. A quick one because of time. So the clockwise turning moment here is like the one that is moving in terms of clock and the one that is moving opposite to clock. I hope you are getting that. So the concept you just need to learn is that clockwise turning moment, CW, clockwise, is equals to anti-clockwise, and it is going to be used to solve a lot of questions under this topic, which is one of the simplest topics at your level. But most of you don't like it because you were not being taught the actual way. So my point is just, I don't need to waste time. So moment is force times distance. If you take by force, 40y force distance must be equals to 10x, as you can see. That is equation 1. I hope students are following. Don't get bored. Don't get bored at all, you right? Then again, the distance from the two, this distance is a meter rule. The distance from here to here is always taken to be 100 centimeter. Take that, or 1 meter. Answers in a centimeter. So I can also form equation 2 that distance x plus distance y is equals to 100. Look at the equation. You can just get anything you want to do and you have your answer. So now you can now try as much as possible and get the value of your x and get the value of your y. So this is just a very simple stuff which you can do on your own. This now is simultaneous equation. You can try and make x of your formula or y of your formula anyhow. From here I can say s is equals to 100 minus y. If I distribute that in this equation, so I can say this is a 40y. I continue from here. 40y is equals to 10 into bracket 100 minus y. So you can see on simplification, see, I can divide both sides by 10 to cancel 10. So 10 here 1 directly, I don't waste time. 10 here 4. This is 4y is equals to 100 minus y. So from simplification, I can say 5y is equals to 20, because if this comes to this side, it's going to give me 5y is equals to, let's say 20, is equals to 100. So simplification is going to give me y is equals to 100 over 5, and that is equals to 20. So if y is 120, x is 80, because x is 100 minus y. So 100 minus 20, that is 8. So I have 80, I have 20. So the center of gravity will be the interval between the x and the y. I'm using simple technical method which you can always use. So the center of gravity is located between x and y. So that is 80 minus 20. So it will be located 80 centimeter away from y and 20 centimeter away from x. So the midpoint, please always get that center of gravity is the center at which the resultant weight at. Now we've gotten x to be 80 centimeter and we've gotten y to be 20 centimeter. So the center of gravity is the center at which all this weight is not going to act. This interval between 80 and 20, then I'm going to equal 60 centimeter. I hope you understand that, and that is how to come about that. Then the next one is the block and tackle system shown in the diagram is used to lift a load of W with an effort E, neglecting friction and the weight of the pulley and the cord. The ratio of effort over weight is dash. Well, I don't think this one should be issue. So we are talking about load over the effort. It's the ratio of E over W is dash. So we need to understand it is E over W. Now we need to understand that the tension that will be used to push this thing is that look at the weight. The weight of the body is always acting. So this is the effort that was applied. So be careful about this. Now here, how many tackle systems do we have? 1, 2, 3, 4. You know that velocity ratio is the numbers of pulley, which is 4. Now, very simple. But we have to understand we have in this diagram, we are divided there. We have 2 movable block and 2 fixed block, 1, 2, and 1, 2. Now, to understand, if I apply a tension T in this direction, in the direction here, let me just show you. Maybe tension to push this. You know, these two up will be what? Will be pulled. Whereby this one will be fixed. Now, what we do in this type of question to understand the effort, you understand, you need to get something. Normally, if I'm looking for the mechanical advantage, it is always the load over the effort. That is the way we interpret it. Now, mechanical advantage is load over effort. The load here is in terms of what? Is in terms of the total number of blocks. How many, the load I am putting on this thing is being placed on 4 block and tackle system. So we say the load is 4 multiplied by the tension, the effort I'm applying to the tension and the strength. Whereby the effort is the tension I'm using to pull the string. Do you understand? But in this case, the examiner asked me for effort over the load, which is the weight. So the effort is the tension I'm using to pull this thing divided by the load. The load is in terms of the total number of blocks that is attached with the force, so which is 40. So in this case, I can say it is what? 1 over 4. But still get cancelled out. 1 over 4. So you need to be careful about it because some of you are just used to just can't know. That is the velocity ratio. But if you want to get mechanical advantage, it's always slow. So tension is always acting away from point of contact. There are contacts. Tension is at what? Always acting away from point of, which is like the effort that you're applying to what? This stuff. So let's say the effort or the tension is T, and the load is in terms of what? The weight that is attached to this, to the string. So the total weight here is the number of block multiplied by what? The tension that is what? Attached to it. So this is the way we tackle block and tackle system. If it is velocity ratio, you just count the number of what? The number of blocks in the tackle. But if it's movable and immovable, you count the number of strings. But I don't think Jamb or UTME do set that one. And please be careful about this type of question so that you don't make mistake. The next one is still machine concept, simple machine concept. A machine has an efficiency of 75. 75%, I'll write it as 0.75. Please. Like I said, I don't have calculator to help you guys. I will intentionally leave it for you guys to work, to solve. The work done when the machine is used to race. So I told you efficiency in the last slide. I mean the last section, that is day 4. That efficiency is also work output over work input. So work output. So the work done when the machine is used. So that is the work input to raise a load of 50 through a vertical distance is that the work done when the machine is used. You are looking for work output over work input. So I don't think this should be the issue. Normally you say times 100. Let me write the full formula. Then you change this one to efficiency. But I've already divided this thing by 100. That's why I'm writing 0.75. This is the efficiency. So the work you put into what something is called the input. About the total work the machine can do is the work input. About the work output is the work that is being carried out by the machine. The work done when the machine is used to raise, that is the amount of work output. And this has done to raise a load of 50 kg. And you know that work is equals to force times displacement. So which you have studied before. You can see force times displacement. Force times displacement. So you can say 500 times 6, that is 3,000 joules. So please keep that at the back there. So the work done when the machine is used to raise a load of 50 kg through a vertical distance of 6 meters. So the work done is work is force times distance. This is mass. We multiply by 10. That is 500 multiplied by 6. And everybody know that is 3,000 joules. So please keep that at the back. Because some questions are just direct. Now, somebody will be thinking, you are looking at the work done when the machine is used to raise it. So that is the total number of work that is being carried out, output, work output. The work done when the machine is used to raise a load of 50 kg through a distance. So the machine work output. So it has worked a load of this and it has moved a distance of this. Simple direct question that doesn't even require you to use. So you are not calculating the work input. So you are just asked to calculate the work output. So the use of this formula is not needed in this type of question. So be careful about this type of question, whereby you think all parameters are going to be used. I always tell my students, knowing concept is very important. Now, the next one is there's a diagram, maybe not drawn well. I just hope there's no mistake. But let's see a particle P. There's a P. Okay, this is the P. Under the action of three forces, F1, F2, and F3, as shown in the diagram, which of the following are correct? Let's see. F3 is the resultant force. We have F2. Okay, F1, I guess. And we have F2. Let me just draw my own. Maybe it should be better for you guys to use my own, at least to understand. And this is the other force. And the resultant force is now acting between them. So let me just say this is my resultant force. That is now acting in between. You know it's coming out. I just want to resolve it to form a component. Don't worry about the diagram, not drawn to scale. So just for you to know, I'm trying to form a rectangle. I said rectangle, triangle. So I'm forming a triangle. So now angle here and angle here now is 90 degrees to each other. Where I know that very well that the F3 is acting along this now. So this is alpha 1, I guess. And this is alpha 2. I will just use the simple concept. So remember this is F1. Remember this is F2. So I can just take them one by one. I'm doing them with respect to, this is the hypotenuse. Please know that with respect to the resultant force which acts between them. So let's take, this is opposite. This is adjacent. I want to get, so the resultant force is acting in such a way that it is adjacent to the two angle. So adjacent, this is adjacent over hypotenuse is cos. So I can say cos alpha 1 is equals to adjacent is the F3 force. That's the force that is acting between them. I'll write it as F3. This one is F3 over F1. On cross multiplication, I can say F3 is equals to F1 cos alpha 1. If I do the same thing to this one, it's also be cos alpha 2 is equals to, look at my 2 is always like alpha. I always tell students that F2 over, I said F2, F3, which is the resultant acting. Let me use a blue, all over. Then we have the F2. I have taken this as the opposite to, I'm taking it with respect to the resultant force F3. This is the F3 over the hypotenuse F2. So make F3, so from I can say F3 is also equals to F2 cos alpha 2. So now directly, my dear student, F3 equals to F3, and say F1 cos alpha 1 is equals to F2 cos alpha 2. So this valid from what I've done because both of them are now equal. Everything is equal to what FK. So I think Roman figure 1 is correct. So without wasting time here, the only option that has Roman figure 1 here is this. All other option doesn't have Roman figure 1. So to save time, so and if we want to talk about the one here that is also balancing it, we can also go by sine over whatever. So I think the correct answer to this is choice A. And this is the easiest way to prove that if I don't want to be doing was using Lamy's theorem. So I can use my knowledge of trigonometry also to break it down. I hope you have understand this. And if you have any issues with understanding any, I told you, you can write a mail to me or drop comments. I will always attend to you. Please do that quickly because I'm a very, very busy one. So when you watch it, drop a comment. I'll definitely attend to you. I want to sure. So let's move on to the next one. The next set of questions here, which I think is the last phase. I'm waiting for this to load. Computer, please. Next question. Good. Very good. Question 9 and question 10. About question 9, which is the last but one. The question 9 says a pulley system has 3 pulleys in the fixed block and 2 in the movable block. Say simple machine. Its velocity ratio is that. Well, we can draw it if we want to draw, but because of time, velocity ratio is the total number of pulleys. That is both in the fixed and what? Movable. So, but please be careful. This is always UTME way. But if the string is drawn, because we can also calculate that the total number of what? Pulley. If we want to draw this thing, the total, if we want to actually look at diagram, this should give us 6. And you can tell me, I will tell you, it's the total number of strings that is attaching the pulley. But normally, velocity ratio of the pulley is the total number of blocks that are drawn in the pulley system. So 3 fixed block and 2 movable block is going to give you what? 5. And that is the answer to that. I think that one is not hard for you guys to understand. Then the next one, I'm basing all questions with respect to your new pattern, and that is why you can see that the questions there are direct. Now, the last question for today is the Earth's gravitational field intensity. We talked about that in the last section of our video. So G is equals to F over M. And from junior classes, we know that gravitational force from law of universal gravitation is G m1 m2 over r squared. I'll help you write it the way you are used to. So here, if you divide one of them, we get cancelled out. So I told you it does not depend on the what? On the mass of the planet. You have talked about that. On the mass of the object, rather. So you now say gravitational force can also be written as Gm. I write it as MP over R squared. So if you don't know, this is also a formula for gravitational field intensity. So GMP over R squared, whereby MP means the mass of the planets. The planets can be Mars, it can be Earth, it can be Venus, it can be any planet. But mostly in your questions, you see Earth. But nowadays, UTM has changed structure. So it will not be Earth. So it may be another planet, the formula still holds. So here you are still going to do what I ask you to do. You are going to substitute value. G is always a constant, even though there is a typo error. It's always 6.67 times 10 to the power negative 11. I'm substituting in this times the mass of the planet is 6 times 10 to the power 24. You are dividing that with square of the radius. The radius is 6.4 times 10 is 6 here, all square. So I leave it to you also to finish. But if you finish well, if I don't make mistake, I think this should give us 9.8 Newton per kilogram. You can say you can say force over mass, Newton over kilogram. So guys, that is where I will stop. Like I said, finish this, punch your calculator. I don't have calculator. I don't have on my system either. So I'm not going to punch any calculator for anybody. But my assumption, I might be wrong. You confirm that and you drop the comments there if I'm wrong with respect to what I have just guessed here. But I think the question should be that I am not the one that prepared the slide. I just say I only monitor the standard of the question. So that is that about that. And that is where I'm going to stop. Don't forget to watch, to like or subscribe to this channel if you find anything interesting or anything that you like. Please also, you can also help us share the content. God bless you and see you guys soon. Bye for now.